last year 24 a little paper, congruence of triangle related theoretical question. Okay, let's see. Write the converse theorem of midpoint theorem. Okay, first of all you should write the converse theorem of midpoint theorem. Thereafter, what it means, converse theorem of midpoint theorem, that means you drew a triangle, it's easy. Okay, what is a midpoint theorem? When we draw a line, okay, when we draw a straight line which is going through midpoint of two sides of a triangle, the line which is going through midpoint of two such sides, that would be parallel to the third side and half of its length. So in opposite, the converse theorem of midpoint theorem, that if a line which is going through, okay, which is intersect, sorry, not intersecting, that is going through two lines, okay, two sides of a triangle, and which is parallel, if that is parallel to the third side and half of its length, those two lines are bisected by that particular line. Okay, I'll repeat again. If this is a midpoint, this one also midpoint, when we connect these 2 points, that will give you this side which is parallel and half of third side's length. The converse theorem of midpoint theorem, that is, if a line which is going through two sides of a triangle, if that particular line is parallel to the third side and half of its length, the line which is intersecting other two sides are their respective midpoints. Likewise, it's better if you drew a diagram. Okay. Thereafter, second, let's see next set of question. The midpoint of side AB. Okay. So by that, if they were asked about the converse theorem of midpoint theorem first, there is a hint. So you should use that particular theorem to solve the following questions. That's easy. The midpoint of side AB of a triangle ABX. Okay, AB of a triangle ABX, midpoint of this one given in the figure as C. Okay, this is the midpoint of AB. So that means midpoint means this length and this length will be bisected by this point C. The straight line going through B, drawn parallel to CX meets AX produced at R. Okay. So the statement was, when you connect C and the point X, which is parallel to this BR, that is the given data. I'll read it again. The straight line through B drawn parallel to CX meets AX produced at R. Okay. So these two are parallel. That's the given data. Thereafter, the straight line through A drawn parallel to CX meet BX produced at S. Okay, produced at S. The same thing. The straight line through... Amma, konja sattam podaingema. The straight line through A drawn parallel to CX meet BX produced at S. Okay. So here also same thing is given. Okay. These two are also parallel. Okay, I'll repeat it again. This line CX, which is parallel to AS, as well. Copy the given figure in your answer script and include the given information. So if you drew it, you will get to write the converse theorem 1 mark, to draw these 2 marks. Okay. Thereafter, second, show the triangle AXS and BXR are congruent. Okay, we need to show these two triangles are congruent. We need to show AXS. This triangle and this triangle are congruent with each other. Okay, before starting to derive the congruence, we need to determine what are the theorems we are going to use. Okay, we know that if these two lines are parallel, look at this in this quadrilateral. If these two lines are parallel, look at this angle and this angle. this angle and this angle both are equal because those are alternate angles. Similarly, look at this. Okay, look at this. So here also we know another one. This one and this one are also same. This one and this one are also same. This one and this one are also same because vertically opposite angle. But we cannot derive by using these three angles. If three angles of a triangle is equals to another triangle's three angles, those are not called as congruent triangles. Those are equivalent, okay, equiangular triangles. So you should, what are the okay, here what are the conditions we need to satisfy to show two triangles are congruent with each other? One is SSS, another one is SAS, ASA, another one is RHS. Here we can remove this one because there is no any right angle in this diagram. Thereafter, look at this. We can show there are two angles. When you need to show two triangles are congruent with each other, that should follow any of these conditions, that should obey any of these conditions. If not, we cannot show two triangles are congruent with each other. Okay, so SSS we can show that. Okay, but now I am going to consider this is a parallelogram. No, two sides are parallel with each other, so this is a parallelogram. So that means this side and this side are equal. Look at this. These are parallel. So in a quadrilateral, if opposite sides are parallel with each other, that is a parallelogram. Okay, that is a parallelogram. If not, look at this. This is a diagonal of this shape, and this one also a diagonal of the shape. Okay, this one also a diagonal of this shape. By using that, you can show that this one and this one are equal. Okay, in a quadrilateral, if diagonals intersect with each other, that will bisect each of their respective lengths. So this one equals to this one and this one equals to this one. Likewise, you can show any of these sides to derive your answer according to any of these conditions. Okay, now first of all, I'll write in triangle AXS, in triangle AXS and triangle BXR, there are two angles. Now already there are many angles, so let's use those two angles and a side to show these two triangles are congruent with each other. So first this, I'll write ASX angle which is equals to XBR. XBR. Why? Those two angles are alternate angles. Alternate angles. When you are showing alternate angles, definitely you should show according to which parallelism these two are alternate angles. If these two are parallel only, we can conclude these two angles are alternate angles. So accordingly, AS parallel to BR. AS parallel to BR. Thereafter, second one is, I'll show this to SXA equals to RXB. Why? Because those two are vertically opposite angles. Vertically opposite angles. Third one would be, you can write this one equals to this one. Okay, I'm going to show this one equals to this one. AX equals to XR because the total length is bisected by this diagonal. So you can write the reason as intersection of diagonals. Intersection of diagonals. There are many theorems here you can use. You can show this one and this one are equal. If not, this one and this one are equal. If not, this and this equal. There are many intersection of diagonals. And thereafter, one more thing, you can show this one and this one as well, because look at this. When you think about this triangle, you can use converse theorem of midpoint theorem as well. When you think about this triangle, okay, think about this triangle. If these two are parallel, the total length of third, okay, total length will be bisected into two equal portions. If this one and this one, third side, is parallel to midpoint of another two sides, that will bisect the total length into two equal portions. By that also you can derive two triangles are congruent with each other. Okay, we just proved three components, this one and this one, this one, this one, and this side and this side. I clearly explained that you can show any of these side, but in reasons you should write the proper reason. It's not compulsory to show. If they were asked about the midpoint theorem, it's not compulsory to show only by using that theorem. There are many other theorems to show here now. So you can use any of them. Then finally, we can write, therefore, triangle AXS congruent with triangle BXR under the condition ASA, angle, side and another angle. This is the way you should show congruence of triangle in the given diagram.